Okay, there are couple of tools that we sort of did not cover, and we deprioritize it at that point in time, which is one is a box plot, which we covered the theoretical part during the basic stats class, wherein we understand how to calculate the quartiles. And the second is, and a couple of more tools which are not there here. Let me just check. Yeah. So there is, so when we talk about the 7 quality tools, there is a tool which is called flowchart, which is more or less like a process map that we have, wherein we talk about the process map which we prepare in the uh, defined phase of a project. So why this is called 7 tools of quality? Because it gives a end-to-end process flow representation from start till the end. And sometimes when you're facing any problem during a project, when you're doing a Six Sigma project, the first thing you look at as a process map. And with the help of process map also, it will give you certain indications that where you need to focus on. It also tells that where the problem, where we went wrong. So process map is such a good, powerful tool which helps you to identify some of the causes as well, wherein it will help you to understand the end-to-end process flow, the non-value added activities as well. And during the project, when you face any challenge, any situation, it is a time to look at the existing process. So therefore, it is recommended to have the process map in place. So that's what is the flow chart, wherein it is representing a process from end to end. So that is what we do in the flow. It's a pictorial representation of a process. It breaks the process into different sub parts. So it could be a very high level, which is a SIPOC that we covered. It could be a level 2 process map. It could be a level 3. It could be a keystroke level as well. So that's why it is that is why it's very important to look at. Then there is another last quality tools, which is the last one in the list, which is called check sheet. Okay, check sheet is a kind of document which is used to collect in a real time, so that we can capture what the irregularities are there in place. So sometimes when the data collection is not there, when there is no check sheet in place, I might not be able to identify where the problem lies. So if you see this example, this is an example of a motor assembly check sheet. Okay, and this is an example of a number of defects which is occurring on different days. So here it's a check sheet which is being maintained, and tomorrow if there is something wrong and when I want to do a root cause analysis or analysis, so this talks about, on the left hand side you see that these are the number of defect types that has come in the service station, and these are the days of the weeks mentioning the occurrences also. Okay, so recommended is that when you working on any process, it is recommended to have a check sheet in place, wherein you are maintaining the logs, wherein you're maintaining the defects, wherein you're maintaining any sort of a trend that you have. Check sheet helps you to identify the problem on a particular occurrence or a particular instance as well. So here in this example, if you see that there is a failure which is supply part rusted, which is happening on mostly all the days. Okay, and it is very easy for you to do the analysis. If tomorrow when you face a problem on this particular defect type, which is masking insufficient, you would see this has come only on Thursday. So you probably would be more careful during the Thursday or before Thursday and see that why it has come in Thursday. So in a nutshell, net check sheet is a powerful tool for data capturing, to identify the irregularities, to identify the inconsistencies, and help us to do the root cause analysis. So these are the two important tools that you can use in your respective processes, within Six Sigma project, outside Six Sigma project, just to ensure that you'll be able to track it. Any question anybody has on the flowchart and check sheet? Are we good? Guys, am I audible to all of you?
Yeah,
I thought for a while the connection gets lost and you're not able to hear me. So I think it was No problem, no problem. So it was pretty simple. I think you all were aware. So that's the reason I did not cover it at the first place. I wanted to cover the important stuff so that we can cover these basic tools at the end. And there is one last tool, which is the box plot. Okay. So so what box plot does is box plot, like in quartiles, we understand that it helps us to define the different quartiles within the different data sets. Okay. Which is Q1, Q2, Q3, and Q4, which is the first 25% of the data, the next 25% of the data, and the last 25% of the data. So if I talk about the box plot, there is a prerequisite to do the box plot. For that, your data has to be continuous. Okay. If your data is continuous, then only you can do the box plot. So the purpose is it has to be to identify the variance in different quartiles and my y has to be continuous. Okay, so the path is stats, graphs, box plot. Let's do that. So we have the data. Okay, so I have this data here. I'm going to plot a box plot. Okay, so box plot, remember, it is a kind of measure of, so box plot basically works on the variance. Like for if my measure of central tendency is mean, what sort of a variation that we take into consideration? What is the best sort of variation? We discussed in the basic stats class. In the
can you repeat the question?
Yes, Ashwini. If in case of, if I have taken a measure of central tendency as mean, okay, what sort of measure of variance that I'll be considering?
Standard deviation.
Standard deviation, absolutely. If my measure of central tendency is median, then what I look at?
Quartiles.
Absolutely. So that's what I wanted to be sure that you are aware of it. So I have the data here. So I go to graph, scatter plot. It's not stats, it's only graph, scatter plot. Sorry, it's not scatter plot, it is box plot. So I go to graph, I click on box plot. Okay, it's very simple. I click on simple, click on OK. So here you notice it only shows the continuous variables. You cannot do a box plot on the discrete data because it will not show you any sort of a variation, because discrete data would have attribute sort of a data. Okay, so let's do it on the HT here. I click on OK. This is the box plot that I have prepared. Okay, you click here, it gives you the Q1, which is 48.75, median 287.5, and median and Q2 is one of the same thing. Q3 489. Okay, IQR range, I will talk about it. Whiskers, I will talk about it, and N, which is number of data point, which is 62. Okay, so this is my Q1, this is my Q2. Okay, and this is my Q3. So when it's Q2, which is my median 287.5, which means 50% of the population, 50% of the population is above 287.5, and 50% of the population is below 287.5. Okay, it says 25% of the population is in 48.75. 75% of the population is between, so 50 to 75 is between 287 to 489. Okay. And the first 25 is 48.75. Whiskers. Whiskers tells me the range. Okay. The lowest value here and the highest value. So looking at this box plot, it tells me the different quartile. It gives me a graphical representation that which of the quartiles I would be working on. So looking at this quartile, what do you think? Which quartile has the maximum sort of variance? Which quartile would you be working on?
Q4.
Because your Q4.
Q1.